Today we're going to learn about special right triangles and also do a trig ratio review. So the first goal for today is to use the properties of 45, 45, 90 and 30, 60, 90 right triangles. In a 45, 45, 90 triangle, this is a right triangle that has, it's an isosceles right triangle. It has two 45-degree angles. Both legs are congruent. Okay, that makes sense since it's isosceles. And the length of the hypotenuse is the square root of 2 times the length of a leg. This is the formula that was just describing. And this is the picture that you'll put in the box on your paper. So you'll draw 45, 45, 90. It doesn't have to be perfect. Just label the 45-degree angles and the right angle. And then put an S on the two legs. Remember, the legs make up the right angle. And then the hypotenuse is the longer side or the side opposite that the right angle is pointing towards. And that one is labeled with an S times the square root of 2. Now, to solve a problem with these types of triangles, there's 5 basic steps. You'll label the triangle with those formulas, the S, S, and S squared of 2 on the hypotenuse. Set the known side equal to the formula, like you're always given a number on one of the sides, and solve for S. Plug S back into those sides that you don't know and simplify. And we always simplify to simplest radical form. Those steps are written out in your notes already. How do you do that? Well, recall that the first step is to label the sides with the formulas. So we know the two legs are S. We don't really need to put an S here, but I'll put it there just because. And this one is your S square root of 2. Now, the known side is this side because S is equal to 9. So I already know that S is equal to 9. So in order to get H, what do you think you would do? Well, go ahead and plug that 9 in for S. So this is just going to be 9 square root of 2. So H is equal to 9 square root of 2. Now the second triangle, I have a side again, which is S, and the hypotenuse I don't know. Just remember that is S square root of 2. Well, if S is 2 square root 2, I'm going to take that and plug it in for S. So I have 2 root 2 times root 2. Remember, when you multiply a radical by itself, a square root radical by itself, it undoes the square root. So basically I have 2 times 2, which is 4. So x equals 4. What is the value of x? So you need to stop the video, try this problem, and then start the video up again. I'm going to keep going. This one is label this equal to S and this equal to S square root 2. So now I have 6 is equal to S square root 2. How would I do that? Well, I know that 6 is equal to S square root 2, but I want S by itself. I need to get rid of that by dividing by square root 2, because I know if I divide something by itself, it equals 1, and that would be 1s. But when I divide this, now I have a radical in the bottom of a fraction, and I can't have that. So I'm going to multiply that side by square root 2 over square root 2, which gives me S equals, because remember this crossed out, 6 square root 2, and square root 2 times square root 2 is 2. When I simplify that, it's just 6 divided by 2, which is 3 square root 2. You can't divide the radical by 2 because that's under the radical, but you can divide the coefficient by 2. You can't divide the radicand by 2. So in this case, S, or x, which is equal to S, is 3 square root 2. The length of the hypotenuse of a 45-45 triangle is 10. The hypotenuse is 10. So in this case, I need to draw the picture. So there's my 45-45-90 right triangle. And I have the hypotenuse, which is 10. So I'm going to label that with S square root 2, and these are both S. So one of the legs is the same as the other leg, so once I get S, I have my answer. So stop the video, try to think about what you would do. I'm going to go ahead and divide by square root 2, and then multiply by square root 2 over 2, square root 2 over square root of 2. So now I've got 10 square root 2 over square root of 2 times square root of 2, which is 2. I almost said 4. 10 divided by 2, because you can only divide the coefficient, not the radicand, would be 5 square root 2 after you simplify. Excuse me. Okay, I'm going to go on and do the 30, 60, 90 rights. Before you go to the 30, 60, 90, you want to try numbers 7 through 12 on the bottom of your page. So stop the video, practice those, check the answers. They are in the answer key that was provided for you. Find the missing side lengths. So these are practice problems. Find the missing side lengths. Leave answers in simplest radical form. We're going to skip that. We're going to go right to the 30, 60, 90 right triangles. The 30, 60, 90 right triangle is also a right triangle, but notice the S is the shortest leg, and the S times the square root of 3 is the longest leg. So the longer leg is square root of 3 times the shorter leg. We start with the shorter leg. The shorter leg is always your basis for these problems. And then the hypotenuse is just 2 times whatever that shorter leg is. If I knew the hypotenuse, I would divide by 2 to get the shorter leg. If I knew the longer leg, I would divide by square root of 3. So draw that picture in the box. Find the values of variables in simplest radical form. We're going to follow the same steps that are on the other side of your paper for the 45, 45 right triangles. So my shortest side is always opposite the 30-degree angle. So if I look across from there, that shortest side is my S. And then remember, hypotenuse is 2S. And longer leg is S square root 3. The longer leg, remember, is always adjacent to the right angle. Okay, so I know what here? I know the longer leg. So I know that 5 is equal to S square root 3. Okay, so it's going to be similar to the 45, 45, right? When you divide by, in those you would divide by square root of 2, but this is square root of 3. So I divide by the square root of 3. And now I have S equals 5 over the square root of 3, but I need to get rid of that, square root of 3. So I multiply numerator and denominator by square root of 3. Now in this case, I end up with 5 root 3 over 3, and that cannot be reduced. So that is S. So now I can plug that in. I know D is equal to 5 root 3 over 3 because it's equal to S. And F is going to be 2 times 5 root 3 over 3. So you need to remember when you multiply by fractions, an integer by a fraction, you just multiply the numerator because this is essentially a 1 in the denominator. So I have 2 times 5. You don't multiply by the radicand, just the coefficient. 10 root 3 over 3. So F is equal to 10 root 3 over 3. And D is equal to 5 root 3 over 3. Go ahead and pause. Go back and try that if you need to. I'm going to go on. Maybe. Okay, so 2 more problems, and then you're going to do some practice problems on those also. This is going to be my shorter leg, so that's S. The longer leg does not have anything on it, but the hypotenuse has a 6 here, so I'm going to set that equal to 2S. So I can find S based on the hypotenuse. This side is X, so I need to know what S is in order to get X. So divide by 2, and S is equal to 3. So X is going to be whatever S is, which is 3. And the last one, I have this triangle is the triangle we're working with. So basically we cut this equilateral triangle in half, and I have a 30, 60, 90, because remember that would have been 60 degrees. When I cut that in half, this is 30. So that makes this S. This is 2S. And then X is going to be equal to S root 3. So I can solve for S here. So S is equal to 12 divided by 2, which is 6. I know this is 6, that's not really. And I'm going to use that to get X. So X equals S square root 3. And remember that S equals 6. So I can plug that in for S. So x is just going to be 6 root 3. Go ahead and practice the problems on the back of on the bottom of that page, and then be ready to review trig ratios. Okay, besides learning about 45, 45, 90, and 30, 60, 90 triangles, we're talking about sine, cosine, and tangent, which you did have in Math 2, so this is just going to be a quick review. Your goal is to use sine, cosine, and tangent to determine side lengths and angle measure in right triangles. Just a quick review. Sine is opposite over hypotenuse. You can shorten that to opposite, OPP over HYP. Adjacent, ADJ over HYP, is cosine, adjacent over hypotenuse. And then tangent is just opposite over adjacent. And we shorten that, or we use a nifty little remembering thing. Can't think of the word all of a sudden. So, sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. And tangent, opposite over adjacent. So, SOHCAHTOA, we call that. So in this triangle, what are the sine, cosine, and tangent ratios for angle T? So we call that our theta. Whatever angle we're using in a trig problem, we call that our angle theta. So basically, sine of theta, or sine of T, equals opposite over hypotenuse. But how do I find the opposite and adjacent angles? Because it's going to change depending on which angle is your theta. Either T or G could be. They told us T is in this problem. Well, the easiest thing is to put your thumb, and I'm not going to use my thumb because you won't be able to see it, over the theta, and look at the two legs. You've got the leg that of RT, which has a length of 15, and you have the leg RG, which has a length of 8. Well, RG is the one my thumb is not touching, so we call that the opposite. The one that the leg you're not touching is opposite. The leg you are touching is adjacent. Remember, adjacent means it's touching something. Adjacent to means you're next to it. And then the hypotenuse, excuse me, is always opposite the right angle. So this is hypotenuse. So always label your three sides when you start. And then write out SOHCAHTOA. And looking at this triangle, well, for this one, we're just going to find sine, cosine, and tangent. When we get to the next problems, we'll finish this part where I said write out SOHCAHTOA. Opposite in this case is 8, and hypotenuse is 17. So sine of t is 8 over 17. Remember, I also need cosine t and tangent t. So cosine is adjacent over hypotenuse. So adjacent over hypotenuse. So that's going to be 15 over 17. And then tangent is opposite over adjacent. So we've got 8 over 15. So that's how you find the three trig ratios. But we're going to do some where we're solving for a missing side. That's where you want to write out SOHCAHTOA when you start the problem. And then you want to label your sides. Well, this is our theta. So when I look at that, I know I'm not touching this leg, so that makes that the opposite. And the other one would be adjacent, which makes this the hypotenuse. So I want to underline the things I have labeled in this triangle. There's nothing on the adjacent side, but there is something, a W, on the opposite side. So I'm going to underline the O's here. And then hypotenuse has a 17 on it. Whichever of the three ratios you have both of the side lengths is the one you want to use. So in this case, I want to use SOHCAHTOA because I have both opposite and hypotenuse. I'm sorry, I want to use sine. So I want to use sine of 54 equals W, because that's opposite, over hypotenuse, which is 17. And to get W by itself, I would have to multiply by that sine. So W is going to be 17 sine 54. When you do this, and you put it in your calculator, you have to make sure your calculator is set to degrees up here. So I want to go to mode, the mode button, and arrow down whoops, right there, and then arrow to the right so that degrees are highlighted, and press enter. Now I can do 17 tangent, I'm sorry, not tangent, 17 sine 54, which equals 13.75, or approximately 13.8. So this is approximately 13.8. The second one, we've got our theta right here. So this is opposite and this is adjacent, which tells me I'm going to be using tangent. Okay, I've got opposite and adjacent. The only one that has both of those in it is tangent. So I'll use tangent, and the angle is 28 degrees, is equal to opposite, which is 1, over adjacent, which is w. So in the kind where the variable is in the denominator of this fraction, you're just going to switch the spots of these two terms, these two pieces of information. So the w will go over here, and the tangent 28 goes on the bottom. You still have a 1 here. So this is what you'll put in your calculator. So 1 divided by tangent 28. And that equals approximately 1.9. The last one, this is my theta, because that's where the 33 is, so I know I have hypotenuse. And the other one is touching my theta, so that's adjacent. So, I have hypotenuse, and I have adjacent, which looks like right now I'm going to do cosine. So cosine, and my angle is 33 degrees, equals adjacent over hypotenuse, so w over 4.5. Now that, when you have the number in the bottom, you always multiply it by whatever your trig function is. So I got 4.5 cosine 33. So what I'll put in is 4.5 cosine 33. And w equals approximately 3.8. Okay, so that's how you find a missing side, but what if you have a missing angle? We use what we call the inverse trig function to do that. I'm going to go ahead and give you the answers to these two. I'm sorry, I'm going to find these two. The inverse trig function looks like this. In this case, my x is my theta, so I know I have opposite over hypotenuse. So SOHCAHTOA tells me I'm going to use sine theta is 6 over 10. Now, how do I get that? Well, we have what we call an inverse sine, which remember a radical, if I square a radical, it's the inverse of it, it undoes it. Same thing here, sine, inverse sine. These two things cancel out, and I'm left with just theta on that side. So I have theta equals inverse sine of 6 over 10. How does that look in the calculator? Well, if you look on sine and where the blue one is, it's inverse sine, that's what you'll use. So you'd press second sine, 6 divided by 10, and that gives you approximately 36.9 degrees. And the second one, we also want x. X is my theta. So let's see, I have adjacent this time, and hypotenuse, which tells me cosine. So cosine x equals adjacent over hypotenuse, or 15 over 20. I take the inverse cosine, that cancels this out, and I just have x. I guess I used theta in the other one, I'm sorry. So I have x is equal to inverse cosine of 15 divided by 20. Put that in your calculator. Second cosine, 15 divided by 20. Notice that I closed the parentheses. It's good to be in the habit of doing that when you're doing these problems. That's approximately, what was that? 41.4. And then our last problem is a measure of angle y to the nearest degree. So now y is my theta. And let's see, I don't have the hypotenuse. I have opposite and adjacent, which tells me I'm going to use tangent. So tangent theta is equal to opposite over adjacent, so 100 over 41. Take the inverse tangent. And I get theta is equal to inverse tangent of 100 over 41. So second tangent 100 divided by 41. And that equals 67.7. So it's approximately 67.7 degrees. And I'm going to stop the video. You're welcome to go back. You're going to get a worksheet to practice this on, which is due tomorrow.